Interpretation of Collection of Dawn, From the Beauty of the Universe to the Dawn of a Nation. Why does a collection blending science and emotion stir the hearts of countless readers? Collection of Dawn is the culmination of Chen-Ning Yang's late-life reflections, chronicling his journey from Nobel Prize laureate to his return to his homeland. This book is not only a beacon in physics, but also a microcosm of a nation emerging from a long night into dawn. Let us follow Chen-Ning Yang's footsteps to explore the interplay of scientific beauty and national aspiration. 1. Emerging from the long night, the mark of Chen-Ning Yang's era. Chen-Ning Yang was born in 1922, growing up during China's modern long night. In the preface to Collection of Dawn, he writes, "The era of Lu Xun, Wen Guowei, and Chen Ying was a long night in Chinese history. My classmates and I at Southwest Associated University grew up in this seemingly endless darkness." These words act as a mirror, reflecting the historical backdrop of his early years. In the early 20th century, China endured foreign invasions and civil wars, with scarce resources for scientific education. Yet, the academic spark at Southwest Associated University ignited his thirst for knowledge. In 1937, when the anti-Japanese War broke out, he followed the university's migration to Kunming, studying under physicist Wu Taoyu and encountering cutting-edge ideas in quantum mechanics and relativity. In war-torn Kunming, classrooms were rudimentary, but professors' chalk-drawn equations shone like stars, illuminating Yang's path to science. That was a golden age for science. Einstein's theory of relativity appended conventional notions of time and space, while quantum mechanics unveiled the mysteries of the microscopic world. Yang recalls in the book how Wu Taoyu's explanation of Heisenberg's uncertainty principle in a classroom at Southwest Associated University left him awestruck by science's power. He writes, "Science is not just knowledge, it is a torch that ignites hope." This conviction drove him to dedicate science to the revival of his nation. In his essay The Responsibility to Build Bridges of Friendship, he calls for Sino-American scientific exchange, stating, "Science knows no borders, but scientists have a homeland." This line encapsulates his response to his era and sets the dual tone of science and patriotism in Collection of Dawn. Take Einstein as an example. His theory of relativity not only transformed physics, but also advanced technology during wartime, demonstrating science's dual power. Deeply influenced, Yang saw science as a bridge to both truth and national service. In the 1940s, he went to study at the University of Chicago under Enrico Fermi, experiencing the global nature of science intertwined with national duty. Fermi, who led the team that built the first nuclear reactor, amazed Yang with how theory could become reality. Yang notes in the book that this experience taught him that science is not just equations, but a tool to change the world. Yang's upbringing was also shaped by his father, Wu Qi-yang, a mathematician who often quoted the I Ching, "Is it better to praise heaven's will or to shape destiny and use it?" This teaching guided Yang to find direction in turbulent times. The harsh conditions at Southwest Associated University toughened his resilience. He recalls reading by kerosene lamp at night, undeterred by mosquito bites in his quest for knowledge. In Collection of Dawn, Yang vividly describes the learning environment at Southwest Associated University. Students crammed onto wooden beds in shabby dorms, with air raid sirens howling outside. He recalls the cold Kunming nights, with wind whistling through broken windows, yet the faint glow of a kerosene lamp warmed his passion for physics. In one class, Wu Taoyu derived Schrodinger's equation on a small blackboard as students sat in a circle, listening intently. This scene made Yang feel the vitality of science. Even amid war, knowledge was a beacon of hope. He writes, "The classrooms at Southwest Associated University were dilapidated, but the ideas shone like stars." Take Chinese physicist Pei Yuan-chu as an example. He taught general relativity at Southwest Associated University, inspiring Yang's thoughts on the structure of the universe. Chu persisted in research during wartime, bringing Einstein's theories to Chinese classrooms and motivating students to serve the nation through science. Yang notes in the book that Chu's classes showed him that physics is not just equations, but a key to understanding the world. This academic perseverance amid chaos shaped Yang's scientific beliefs and infused his research with hopes for national revival. This era's imprint runs through Collection of Dawn, lending each passage the weight of history and the light of hope. This chapter weaves historical context with personal experiences, guiding us to Yang's starting point and revealing why his science and emotions are so deeply intertwined. 2. Parity non-conservation. The beauty of breaking symmetry. What is the beauty of physics? In discrete symmetries P, T, and C, Yang answers, beauty lies in symmetry and the courage to break it. This essay is the heart of Collection of Dawn, recounting how Yang and Sungdao Li won the 1957 Nobel Prize in Physics for their theory of parity non-conservation. Parity conservation was once an unassailable law in physics, asserting that nature's laws are mirror symmetric. Yang and Li proposed that in weak interactions, parity might not hold. This hypothesis was like toppling a grand edifice, and Wu Chen-Shun's experiment ultimately confirmed their prediction, shocking the scientific community. The book includes a letter from Wu Chen. Dear Chen-Ning, your insight opened new possibilities in physics. This letter highlights the value of collaboration and the challenges of scientific discovery. To help lay readers understand parity non-conservation, Yang likens it to a world in the mirror that is no longer symmetric. Imagine raising your right hand, but your mirror image raises its left. This is the intuitive picture of parity conservation. But in certain particle reactions, like beta decay, the mirror world differs from reality, with electrons favoring one direction. This non-conservation reshaped our understanding of the universe. He writes, discovering the beauty of asymmetry requires greater courage. Take British physicist Paul Dirac as an example. His equation predicted antimatter, similarly appending conventional wisdom. In Beauty and Physics, Yang compares Dirac's equation to a Gothic cathedral for its elegant mathematical structure that holds the sublime beauty of the universe. Dirac's story inspired Yang, who recalls in the book how he and Li stayed up all night in Princeton in 1956, deriving equations to challenge a half-century-old law. They started with the simple question, why do weak interactions behave differently from electromagnetic ones? Through mathematical derivations, they found flaws in parity conservation, ultimately overturning it. Yang emphasizes that scientific discovery requires vision, persistence, and drive. He recalls that when they proposed parity non-conservation, many peers dismissed it as fanciful, but Wu Chen-Shun's experimental results silenced the skeptics. Wu's cobalt-60 experiment confirmed the asymmetry of electron emissions, not only validating the theory, but also opening a new chapter in particle physics. To make it more relatable, Yang compares this discovery to finding an unexpected step in the universe's dance. To further clarify parity non-conservation for lay readers, Yang uses a vivid analogy. Imagine playing with a deck of cards where the rules demand that red and black cards remain balanced after each shuffle. But suddenly, one shuffle consistently yields more red cards. Define your expectations. Parity non-conservation is like this surprise, revealing that the universe doesn't always follow symmetric rules. He writes, this surprise forces us to rethink the essence of nature. Take American physicist Richard Feynman as an example. His path integral theory offered new perspectives on particle behavior, inspiring Yang's exploration of asymmetry. Feynman once used the analogy of ants crawling on a chessboard to explain quantum mechanics, emphasizing that all possible paths determine the outcome. Inspired by this, Yang viewed parity non-conservation as a path choice, where particles in weak interactions prefer certain paths. This analogy makes complex theories tangible and accessible. Yang also notes in Collection of Dawn that the discovery of parity non-conservation transcended physics, prompting philosophical reflections. If the universe isn't perfectly symmetric, must human cognition also break from convention? This interdisciplinary insight adds intellectual depth to Collection of Dawn. Such analogies turn high physics into poetry, inviting readers into the temple of science. The book further explains that parity non-conservation reshaped thinking about fundamental particle behavior, influencing the development of the Standard Model. For instance, experiments at CERN's particle accelerators continue to probe deeper mysteries of asymmetry. This chapter, through analogies and stories, not only showcases Yang's scientific achievements, but also conveys the and poetry of science. 3. Gauge fields and statistical mechanics, the language and order of the universe. How does physics describe the language of the universe? In the essay Gauge Fields, Collection of Dawn provides an answer. Gauge fields are the unified language connecting electricity, magnetism, light, and gravity. Yang traces the origins of this theory, from Maxwell's 19th-century electromagnetic theory to the modern Standard Model of particle physics. He writes, "Gauge fields are the language of physics, unifying natures for fundamental forces." To make it accessible to lay readers, he compares gauge fields to the universe's symphony, with each force as an instrument playing in harmony. Electromagnetic force is like a violin, light and pervasive. Gravity is like a cello, deep and far-reaching. Gauge field theory ensures these instruments play by a unified rule. Take German mathematician Hermann Weyl as an example. His work on group theory inspired Yang. Weyl proposed the concept of gauge invariance, attempting to unify electromagnetism and gravity, akin to a map that remains true no matter how it's rotated. In Weyl's contribution to physics, Yang praises Weyl's style with the Chinese literary term "xingling," spiritual charm, blending science with elegance. Yang developed non-abelian gauge fields, solving key problems in particle physics and laying the foundation for the Standard Model. This theory is like a puzzle, connecting the behavior of microscopic particles to the laws of the macroscopic universe. For example, gauge field theory explains how photons mediate electromagnetic force, helping us understand the nature of light and electricity. Yang further explains in the book that gauge field theory not only describes photons, but also reveals the mechanisms of weak and strong nuclear forces. For instance, W and Z bosons act as messengers of the weak force, playing a critical role in radioactive decay. He likens these particles to the universe's mail carriers, delivering nature's fundamental instructions. This analogy helps lay readers visualize the workings of the microscopic world, as if particles are sending messages to maintain cosmic harmony. Take British physicist Peter Higgs as an example. His Higgs field theory added a crucial piece to gauge field theory. Higgs proposed that particles gain mass by interacting with the Higgs field, similar to walking through water and feeling resistance. Yang highly praises Higgs's work in Collection of Dawn, noting that it completed the Standard Model's puzzle. He writes, "The Higgs field makes the universe's symphony more complete." In 2012, CERN's Large Hadron Collider confirmed the existence of the Higgs boson, validating Yang's early insights into gauge fields. This leap from theory to experiment showcases the allure of science and lets readers appreciate the profound impact of gauge field theory. In the field of statistical mechanics, My Journey in Statistical Mechanics recounts Yang's research path. Collaborating with Lars Onsager, he solved the two-dimensional Ising model, uncovering the secrets of phase transitions. For example, the melting of ice into water seems simple, but involves the coordinated motion of billions of molecules. Yang compares this to extracting order from chaos, like conducting a grand molecular chorus. He writes, "The beauty of statistical mechanics lies in finding macroscopic laws from microscopic chaos." Take Japanese physicist Hideki Yukawa as an example. His research on strong interactions inspired Yang's thinking on phase transitions. Yukawa used statistical methods to reveal the mysteries of nuclear forces, opening new windows in particle physics. To help readers grasp statistical mechanics, Yang uses a relatable example. Imagine a crowd wandering randomly in a plaza, then starting to dance in unison upon hearing music. Phase transitions are like this: shift from disorder to order. Yang's research not only applies to physics, but also inspired material science, such as the development of superconductors. These essays, through analogies and examples, make complex theories vivid and engaging. Yang notes in the book that the universality of statistical mechanics showed him science's boundless possibilities, like seeing an ocean in a single drop of water. This chapter also explores Yang's philosophical reflections on science. He believes gauge fields and statistical mechanics are not just technical tools, but keys to understanding cosmic order. Quoting Einstein, he writes, "The comprehensibility of the universe is the greatest miracle." Through accessible language, Collection of Dawn allows lay readers to glimpse the depth and charm of science. 4. The power of friendship, the emotional bonds behind science. What drives scientific discovery? In modern physics and passionate friendships, Collection of Dawn answers, friendship and collaboration are the cornerstones of scientific success. Yang writes, without Wu Chen-Chung's experiment, parity non-conservation would have remained mere theory. Wu's cobalt-60 experiment validated the parity non-conservation theory, with her rigor and courage being pivotal to the collaboration. The book includes a letter from Wu. "Your theory pushed me to rethink the boundaries of experimentation." This correspondence not only showcases academic collaboration, but also reveals the deep trust between scientists. Take Italian physicist Enrico Fermi as an example. At the University of Chicago, he mentored Yang, teaching him to bridge theory and experiment. Fermi once said, "Physics is a dialogue between experiment and theory." After a failed experiment, Fermi encouraged Yang, "Seek truth from mistakes." This experience, documented in a true story, became a driving force for Yang's persistence. Yang recalls how Fermi's calm and innovative approach in nuclear reactor experiments taught him to find breakthroughs in complex problems. He writes, "Fermi's lab was like a crucible of ideas, where everyone contributed sparks to the pursuit of truth." The book also includes correspondence with Marshall Rosenbluth, discussing challenges in nuclear physics calculations. Rosenbluth wrote, "Your calculations made me rethink the boundaries of our model." These letters reveal the mutual inspiration among scientists. For example, Rosenbluth's plasma research provided insights for Yang's gauge field theory. Yang reflects in the book that scientific progress is like a relay race, with each person running a leg toward the finish line. Yang extends friendship to cultural exchange. In 1971, during his first visit to China, he shared gauge field theory with Chinese scientists, sparking the beginning of Sino-American academic exchange. In The Responsibility to Build Bridges of Friendship, he writes, "Science is humanity's shared language." Take Qian Zhusen as an example. His return to China inspired Yang. Overcoming immense obstacles, Qian laid the foundation for China's aerospace program, embodying a scientist's patriotism. Yang recalls meeting Qian in Beijing in 1971, discussing the future of Chinese science with shared optimism. This encounter was not just an academic exchange, but a meeting of hearts. Yang describes in the book how Qian showed him China's research labs, where, despite rudimentary equipment, the researcher's passion moved him deeply. Qian shared the challenges of aerospace projects, achieving technological breakthroughs with limited resources. Yang was touched, writing, "Scientific progress requires passion and, above all, conviction." This visit marked a reconnection with his homeland, strengthening his resolve to contribute to Chinese science. Take Chinese physicist Zhao Zhongyao as another example. A close friend of Yang, he discovered positron-electron pair annihilation in the 1930s, laying a foundation for particle physics. Zhao persisted in research during wartime, even crafting experimental equipment by hand. In Zhao Zhongyao and the Creation and Annihilation of Positron-Electron Pairs, Yang writes, "Mr. Zhao's perseverance showed me the heart of a scientist." This friendship not only fostered academic exchange, but also inspired Yang to connect science with national revival. These stories reveal that behind science's triumphs lies the trust and collaboration of countless individuals. Collection of Dawn also records Yang's friendship with Deng Jiaxian. Deng, who devoted himself to nuclear weapons research, is described by Yang as, "Jiaxian's dedication showed me the soul of a scientist." These emotional bonds not only advanced science, but also infused hope into national revival. Like Newton standing on the shoulders of giants, Yang's achievements were supported by friendships. This chapter, for real stories and quotes, lets us feel the human warmth behind science's brilliance. Patriotism, from Southwest Associated University to Tsinghua's return. What is a scientist's mission? In China's scientific achievements are a historical miracle. Collection of Dawn offers Yang's answer. Science lights the dawn of national revival. He writes, "A decade of reform and opening up has brought remarkable economic achievements." He highly praises China's scientific progress, seeing it as a historical miracle emerging from the long night. For example, he highlights the leap in computer technology, from early lag to global leadership, securing China's place in information technology. Take Deng Jiaxian as an example. In remembering Deng Jiaxian, Yang fondly recalls this father of the two bombs. Deng gave up a comfortable life in the US to work on nuclear weapons, ultimately succumbing to radiation illness. Yang writes, "Jiaxian's sacrifice is a beacon for Chinese science." This passage not only honors a friend, but also expresses pride in national scientific achievements. Deng's story is deeply moving. Leading a team in the desert, overcoming equipment shortages, he successfully tested an atomic bomb, building a shield for national security. Yang recalls that during his 1971 visit to China, Deng showed him the country's research progress, filling him with hope for national revival. In 2003, at age 82, Yang settled at Tsinghua University, dedicating himself to nurturing young scientists. In changing the concept of sending students abroad, he suggests focusing on practical innovation, cultivating entrepreneurs like Bill Gates, rather than chasing Nobel Prizes. He compares innovation to planting trees, emphasizing the importance of foundational education over hasty fruit picking. For instance, he opposed blindly building massive particle colliders, advocating instead for resources to be invested in basic research and education. This view stems from his deep historical insight. At Southwest Associated University, despite primitive conditions, solid foundations produced numerous talents. Take Hua Luozheng as an example. This mathematician returned to China and promoted applied mathematics, optimizing industrial production. Hua used operations research to streamline the construction of the Chengdu-Kunming Railway, saving vast resources. Inspired by Hua, Yang advocated for science to serve society. He notes in the book that China's scientific progress is not just about hardware, but the emergence of talent. For example, Tsinghua's research teams have made breakthroughs in quantum computing, showcasing the potential of the younger generation. Yang vividly describes Tsinghua's research atmosphere. Young students in labs explore the frontiers of quantum computing, tackling problems traditional computers cannot solve. He likens quantum computing to the key to the future, unlocking solutions from drug design to climate modeling. He writes, "These young people let me see the dawn of science." Take Chinese scientist Xu Chengjiang as an example. His work in topological quantum computing inspired Yang. Jiang proposed that topological materials could build stable quantum computers, addressing error rates in traditional computing. In a Tsinghua lecture, Yang cited Jiang's work as a new hope for Chinese science. He believes quantum computing breakthroughs represent not just technological progress, but the passion and creativity of the younger generation. These achievements convinced Yang that China's scientific future is bright. He emphasizes in the book that nurturing young talent is not only the continuation of science, but the key to national revival. Yang also focuses on the fusion of science and culture. In Ode to the Great Wall, he writes, "The Great Wall is the backbone of the Chinese nation, and science is the hope of the future." He believes technological progress requires cultural support, just as cultural revival needs science's nourishment. This, through analogies and real examples, helps lay readers understand the link between science and national development, inspiring us to contribute to national revival. Philosopher and mortal, Chen-Ning Yang's inner world. How does a scientist face life? Through personal stories, Collection of Dawn reveals Yang as an ordinary human. In response to the Yang-Weng marriage, he candidly addresses public controversy, writing, "In 30 or 40 years, this will be seen as a romance." His decision to remarry at 82 reflects his steadfastness and ease in love. Wang Fan, his life partner, also helped compile Collection of Dawn, infusing vitality into organizing his thoughts. Yang recalls how Wang often discussed the connections between physics and culture during the editing process, giving him a sense of intellectual continuity. Take his father, Wu Qi-yang, as an example. He quoted the I Ching to guide Yang, "Is it better to praise heaven's will or to shape destiny and use it?" This teaching inspired Yang to take initiative in both science and life. He writes in the book that his father's guidance helped him find direction in adversity. For example, during the harsh conditions at Southwest Associated University, he persisted in studying quantum mechanics under a kerosene lamp. Yang recalls a memorable moment. In the 1940s, during a Kunming blackout caused by air raids, he and classmates discussed Schrodinger's wave function by candlelight, the flickering flame igniting intellectual sparks. He writes, "The candlelight in the darkness taught me that science is the light within." This passion for knowledge sustained his academic career and became his strength in facing life's challenges. Take French philosopher Jean-Paul Sartre as an example. His existentialism emphasizes that humans must take responsibility for their lives. Though Yang doesn't directly cite Sartre, his reflections resonate with this idea. He notes in the book that his pursuit of science gave him purpose amid wartime chaos, while his choice in love brought warmth in his later years. He recalls meeting Wang Fan at an academic conference. Her question sparked a sense of vitality in the younger generation, igniting a new emotional spark. This blend of philosopher and mortal makes Collection of Dawn not just a scientific anthology, but a philosophical reflection on life. Yang also recalls how his father took him to visit the Great Wall, its grandeur instilling a sense of national pride and reinforcing his commitment to serve the country through science. Yang's philosophy also shines in his reflections on life. In Modern Physics and Passionate Friendships, he writes, "Science is finite, but life is infinite." This echoes German philosopher Martin Heidegger's idea, humans are beings thrown into the world. Yang responds to this thrownness through scientific exploration, seeking order in life. For instance, he recalls that science gave him direction during the confusion of wartime, while love gave him courage amid public scrutiny in his later years. He shares a small story. In the 1970s, gazing at the starry sky in Princeton, he contemplated the vastness of the universe and the brevity of life. This reflection connects science with life's deeper meaning. He writes, "Physics reveals the universe's order, life reveals its transience." This philosophical depth makes Yang relatable. He is not just a Nobel laureate, but a mortal grappling with love, family, and life's uncertainties. This chapter, through analogies and stories, conveys Yang's warmth and depth. Dawn's First Light, the hope and future of science. Collection of Dawn concludes with 16 color illustrations, symbolizing the first light of dawn, with radiant brilliance still to come. Yang writes, "At 85, I won't see the full dawn. Wang Fan has promised to see it for me." These words are both a personal farewell and a hope for the future. He believes that scientific progress and national revival will bloom like dawn. Take Stephen Hawking as an example. In A Brief History of Time, he wrote, "Curiosity is the driving force of human progress." Echoing this, Yang established a scholarship at Tsinghua to nurture young physicists, perpetuating the dream of science. In Beauty and Physics, he emphasizes that the beauty of science lies in inspiring the next generation. For example, a young Tsinghua team made breakthroughs in quantum entanglement, validating Yang's earlier theoretical conjectures. He writes in the book, "The curiosity of the young is the future of science." Collection of Dawn is not only Yang's personal anthology, but a microcosm of 20th century science and national history. From the breakthrough of parity non-conservation to the heartfelt return to his homeland, it showcases a scientist's multifaceted life. Yang also looks to the future of science. Technologies like artificial intelligence and quantum computing will reshape the world. He explains with an analogy, if gauge fields are the universe's language, AI will be humanity's second language. He encourages young people to embrace new technologies while maintaining reverence for truth. Take Chinese scientist Pan Jinwei as an example. His breakthroughs in quantum communication delighted Yang. Pan's MISSIS project achieved the world's first quantum communication experiment, advancing the development of quantum networks. Yang notes in the book that he once discussed the philosophical implications of quantum entanglement with Pan. Two particles, no matter how far apart, can instantly affect each other, as if the universe shares an invisible bond. He likens quantum entanglement to the universe's tacit understanding, making science's wonders accessible to lay readers. He writes, "Pan Jinwei's work convinces me that the future of science belongs to those who dare to dream." Take British scientist Alan Turing as an example. His computational theory laid the foundation for AI, aligning with Yang's vision for science's future. In Collection of Dawn, Yang suggests that AI could become a new tool for understanding the universe, much like gauge field theory provided a language for particle physics. In a lecture, he said, AI is like a mirror, reflecting both human wisdom and limitations. He encourages young people to explore the intersection of AI and physics, such as using machine learning to optimize particle collision experiments. This interdisciplinary vision makes Collection of Dawn not just a look back, but a pointer to science's future. Pan Jinwei's MISSIS quantum satellite achieved the world's first quantum communication experiment, showcasing China's scientific rise. Yang noted in a lecture, "Seeing these achievements, I believe the dawn has arrived." Collection of Dawn inspires us to pursue scientific truth and contribute to the nation's future. From physics equations to patriotic fervor, Yang ignites the dawn with reason and emotion. Whether you're a scholar chasing truth or an ordinary person concerned for the nation's future, this book lights a lamp in your heart. As Yang says, "The dawn has come, and the future is bright." Let us follow his footsteps to embrace the brilliance of science and the radiance of our nation.